Hi, my name is Lindsay Luminate and I teach 7th grade math at Letcher High School in St. James Parish. As an educator, I can only hope that I make a positive impact in my students' lives. I truly believe in creating a positive environment where my students feel comfortable with taking educational risks. The following video is of my 7th grade math class. Eureka Math Squared is a high-quality curriculum used in my classroom. Our district uses this curriculum with fidelity. Today's lesson is a station-based lesson that reinforces skills from the topic by having students apply properties of operations to expressions involving rational numbers. In groups, students encounter tasks that require them to analyze expressions in context, create equivalent expressions, and explain the meaning of expressions in context. The end goal for students is to use what they know about equivalent expressions, such as combining like terms and using the distributive property to solve various types of equations and inequalities. This class includes special education students. Therefore, there is a special education teacher in this class during my lesson. She is there to support those students during our lesson today. Let's turn to your Lesson 6 fluency. Today's key question is how can we write expressions so we can easily compare them and determine whether they are equivalent. Remember that our fluency is going to get us started for today's lesson. Read your directions and get busy. Another way we can write this equation. Walking, I saw just maybe a few little mistakes, but we're getting better with our distributive property. I'm going to go ahead and circle this here because I want you to know that this plus 4 has nothing to do with the 2 that's going to be distributed to the parentheses here. That's a whole different, we don't even do anything with that, okay? So whenever I look at this 2, it's going to be distributed to the parentheses. So 2 times x is 2x. 2 times 3 is going to be 6. I went ahead and just copied the sign right here. We can't ever change our signs. I can't say, ooh, I feel like this one should be a plus sign. We don't get to do that, okay?
Good morning, school.
I get negative 6 plus 4. We have a different signs here. What do I do with negative 6 plus 4?
Subtract and turn the signs larger.
So what's my final answer for this one?
2x minus 2.
2x minus 2. I'm going to tell you to circle this one. Is this the only way I could write this equation?
No.
What is the equivalent equation for this one, Bree?
2x plus negative 2.
2x plus negative 2, right? Which one am I going to tell you to use?
The first one.
The first one, because less is when we're preparing ourselves for when we actually have to solve equations. We don't want to have to deal with all these signs when we're solving equations. All right, let's skip and go to number 3. Why do you think I chose number 3 to go over? What do you see? A negative. Because that negative 2 is going to change everything in the parentheses. We have to know our signs, guys. Our sign rules. Negative 2 times 3x is what? Negative 6x. Negative 2 times positive 1 is what?
Negative 2.
Negative 2 plus 6. I can combine like terms here of negative 2 plus 6. That's just me taking 6 minus 2, right? What's my final answer? Kennedy said negative 6x plus 4. What do you think? That's it. Could I say that that I could simplify this more and say negative 2x? Can I combine all these numbers? No, I can't. I need you to know that, okay? We cannot combine the positive 4 and the negative 6x because what does 4 not have? A variable. We can't just combine these two. All right? Let's close our fluency. Pass them to the front. You know who you are to put them in the bucket. And then I need you to open your book to page 67. Oh, goodness. Okay. You're going to have 30 seconds to evaluate this expression. All right. Time is up. I see some of your faces. Let's look at this next slide. As I walked around, I saw a lot of you use the distributive property, right? And combining like terms. If you did, give me a thumbs up. It's fine if you did. That's one of the strategies. I tell you all the time, you use the strategy that works for you. You do you, boo. That's one of our famous sayings in here. You do what works for you. So when you distributed, some of you, your face went in panic because what do they have here?
A fraction.
Fractions. This problem is very intimidating. But let's look how if we factored, remember when we used the tabular model? If I factored here for this one, if I look at what's inside the parentheses, what do we notice?
It's the same.
It's the same thing. So today you will use what you know about equivalent expressions as you work in stations. Guys, your stations are in your book. I want you to get where you're there. You're on page 67. Do you see station 1? Look at station 1. Station 1 is the structure of the expression. That's what I was talking about as we did that launch. The structure of the expression. Bring your eyes to those parentheses, okay? Ask yourself questions and your group questions. It'll make you understand it. Turn the page and let's look at what we're going to do for station number 2. Station 2 is context in factoring. Which word did you hear when I said the title of that station? Factoring. When we factored, what could we use if we needed to factor something? What visual representation could we use if we needed to? The tabular model. We're going to be in this station looking for the mistake, okay? It makes us aware of our rules here. So, let's go ahead. You're going to get with your groups, your normal groups of 4, okay? So let's quietly turn our desk real quick, and I'll go ahead and give you your directions and your station number. If your group did not finish a station in the allotted time, I want you to return to that problem. So let's say the next set of stations you didn't finish your first station. I would prefer you to go back to your station and work on that independently, okay? If you finish it, this is what you have. Capiche? All right. Any questions on what we're going to do here? You're going to read your station, read the directions, and every one of you is recording your answers in your book because then you're going to compare answers. Okay? Work together. Have fun. Ready? You have 8 minutes. Okay. What is the side length of one side of the square?
2/3.
Is it just 2/3?
2/3
Plus?
plus 1.
Okay, so that's your side length. But you just told me that it's the square. How many sides of the square? How many sides in a square does a square have? 4.
So it's 2/3 g plus 1 times 4.
Because you're going to distribute the 4 to each side length. So maybe above this parentheses, I would put side length. If you need to draw a square, that don't really look like a square. And say 2,3G plus 1 to see it, do it. Because this is 2,3G plus 1, 2/3 G plus 1, 2/3 G plus 1, 2/3 G plus 1. Do I really want to write all of that? So you would use what you said.
Moore states that negative 3x plus 2 plus 4x and 4x minus 3x plus 2 are equivalent. Explain why you agree or disagree.
You see how it has the 10 minus 4? You subtracted 10 minus 4, right?
Yeah.
You can't do that. What number is attached to the parentheses here? The 4. So you're going to go ahead and distribute the 4 to everything in the parentheses. Then you're going to go ahead and combine your like terms. Your answer is going to be a little different than what you have. Okay? I want you to check it out. Let me make sure you have this right. Okay, yes, you do 6x plus 3y.
3y?
Yeah. Let me see what you did here. Right here. What's 8 minus 5? 3. Okay, so what you didn't do here is distribute the 3 to the y. Make sure you put that there. It'll mess up your whole problem. Brantley, let me see your real quick before. Yes, okay. So for letter C, when it says how does the answer in part B relate to 2y plus x, how could you have predicted that? Look at 6x plus 3y. When we did the tabular model the opposite day, remember whenever we went ahead and we had the actual answer inside of the tabular model, and then we had to measure it? Try that. That's it. Come back to this one. You can go ahead and turn your paper to your next station and get ready. Give me a thumbs up when you're ready. All right, let's go ahead. Your next station, you have 8 minutes. We solve that expression. That's what you need to do. Alright, finish your thoughts at that station. Y'all are doing some great work here. I love the conversations, I love the wording, the words that I'm hearing, the equivalent, the commutative property. After the video segment and when students finish their rotations, I gave them 3 minutes to analyze their work from a study guide answer key that was posted on Google Classroom. The last step of this lesson is an exit ticket. Students complete this independently. This is where I get to chat with my students, see what their struggles are and what they need extra help with. It's actually my favorite part of my lesson daily with my students. I do think that the objectives for this lesson were met. There were different checks of understanding throughout the lesson. My students used vocabulary words that were expected of them as well as those that are not always expected. Lots of them use different strategies, and I always welcome my students using different strategies. Not all students like to show their work a certain way, and I'm very open to the term, and you may even hear me say it in the video segment of you do you. It's what makes them comfortable. I don't think there is anything that I would do differently in this particular lesson. I really liked the way Eureka had this lesson set up. Each station was a very important topic that we hit every day this week. So this was more of a review to prepare my students for their test tomorrow. I did add a minor adjustment to this lesson. Eureka stated 5 minutes per station. However, I didn't feel that 5 minutes was enough time, so I increased my time to 8 minutes, which I felt was perfect.